Hello dear students, today we shall be discussing about the convectional current theory or also called as the seafloor spreading. Popular, the, the person who postulated this theory was Edward Suez. This was the person that came up with the convectional current theory. See, in geography that we study, there is a major part of geographical study known as the geomorphology. Geomorphology, which means the study of the physical features that are present on the planet Earth. Now, what are the physical features of the planet? You have hills, mountains, plains, plateaus, etc. So, all these are considered the physical features of geography. So, how are these physical features formed? There are essentially two ways in which a physical feature may be formed. That is either via deposition or erosion. And the third part is the plate tectonic or the movement of the plates. Now, what are plates? As we have studied, the earth is classified into the crust, mantle, and core. Now, this crust is not stable in the sense the crust is in a state of continuous motion, undergoing various changes, whereas mantle and core are maintain their structural integrity since the formation of the earth. Now, this crust is supposedly floating on the mantle and core, and since the crust floats on mantle and core, the entire crust is not one single entity. There are various cracks within the crust which we call as plates. These plates are also known as lithospheric slabs. So, plates which are also called as lithospheric slabs are freely floating over the mantle and core, and since these plates are not constant, they are in a continuous state of motion. They undergo various physiological processes leading to the formation of various physical features. Now, Edward Suez attempted to explain to the world how exactly do these plates move. The best example for seafloor spreading is the mid Atlantic ridge. We have a physical feature present between the North and South America as well as Europe and Africa. These are both your Americas, North and South America. This is Europe, this is Africa. The ocean that is located in between these continents is known as the Atlantic Ocean. So, what are mid-Atlantic ridges? Ridges are small hills or small hills that are found along the longitudinal extent of the Atlantic Ocean. Here you will see these are parallel mountain ranges that are found within the Atlantic Ocean. According to Edward Suez, see, this is your lithosphere. These are different plates. Underneath the plates, we know that asthenosphere is in a state of molten lava. So therefore, within the asthenosphere present below the plates, there is something called as a convectional current. Due to the nature of the core and the rotation of the earth, these convectional currents are born. They travel in such. Now, this entire part is magma which is in a molten state. Now, since the earth has a solid core and it is always in a constant state of rotation, these convectional currents are born in such a direction. This is the path of the convectional current. What it essentially means is the magma within the asthenosphere is following this pattern or is moving in this direction. So when such a phenomenon occurs, there there arises a crack in the crust, and from this crack lava seeps out to form your Atlantic ridges or say mountains. So in this process, when lava exits the asthenosphere and comes to the surface, it also pushes the plates outwards. Now this plate will subduct under another plate, leading to again formation of mountains. The best example is the mid-Atlantic ridge and the Appalachian mountains, where you see the plates subducting under the American continent and forming the mountain ranges that run parallel to the ocean. So this is how Edward Suez postulates the theory that the, the magma which is present beneath the crust is responsible for the movement of plates. So with time, now as you can see, I have drawn various mountains. I have not drawn a single mountain. It is because every time there is an eruption and formation of a mountain, the water, since it is all occurring under water, these mountain ranges are subjected to erosion. Therefore, they reduce in size. The smaller the ridge, it means that the older it has been formed. Now, with time, even this mountain will separate and become similar to these, which gives a clear idea that the sea floor is not constant, but it is spreading at a defined rate set by the convectional current. So this is the basis of convectional current. Various other studies after Edward Suez were compiled, and finally the plate tectonic theory was born. So thank you.